All right. Hope y'all are doing well today. Today we're going to be working on a little code snippet that goes over object-oriented programming. Uh, In this case, the object is a concert object that we've defined from lines 1 through 18. And then we're going to be doing some stuff with this object, or an object that we create on the next couple lines, next few lines. Now, this memory diagram kind of can be intuited. Once you kind of start to notice a pattern, it might make it easy to go through it without actually reading the code. However, I would encourage you not to do this. With the whole purpose of memory diagrams is to teach you to read like a computer. Uh, Especially like when we test you in your quiz setting, oftentimes we're giving you nonsensical class names or variables because we want to test your ability to read like a computer. These are kind of fun when you're going through and practicing memory diagrams. It's nice to not have just variables named X and foo and blah and things like that, but I would still encourage you just kind of process this line by line. So teaching to read like a computer. So as always, I like to reiterate: computers read top to bottom, reading one line at a time. They remember what they're told to remember. They don't remember anything else. They also read left to right, and then they'll read inside to out. When I say inside to out, I mean, let's see, where's an example here? So inside to out, we have this print statement right here, right? Until we evaluate what name, seat, and self-artist are, add them to these strings, we cannot print this. This whole expression needs to be evaluated before we can do this print statement. Oh, that out of the way, let's get started. All right, line one. Line one's doing something. What's it doing? It's creating class definition. It's like a function. We don't actually step into anything indented underneath here until we're told to do so. So until we're told to do so, we just store it for later. So over in globals, we're going to create a concert variable. Oh my goodness. Concert variable. And over in the stack, we're going to store its definition. So first available ID is ID 0. It's of type class. And it's defined from lines 1 through the last indented line, so line 17. It's 1 through 17. Oh, until we're told to do so, we don't step into it, so we skip right on down to line 19. Now, line 19 creates a new global variable. We know it's global because we're still in our globals frame. We're still right here. So the new variable's name is going to be called Lenovo string, or excuse me, Lenovo seats. It's of type dictionary, where the keys are strings and the values associated with them are booleans. And then we're assigning to it values. So let's get started. Lenovo seats. Lenovo seats. Name of our variable. Just like we will be doing with our concert object, our dictionary is an object. So we have to store it in the heap. So create new ID. Just making sure I have room. Yep. Okay. New ID. It's going to be of type dictionary of strings and bools. And then we need to add some key value pairs. So let's make some room here. What's our first key value pair? Well, In dictionary literals, key value pairs are separated by these commas, and then keys and values are separated by colons. So our first key value pair is this right here. Key, it's the string k1, and the value is a Boolean true. So k1 is our string, and true is our bool. Side note, just remember, we're in the heap. We're defining our key as a string, so we gotta have these little quotes here. Then we go and do the exact same thing for the next two key value pairs. We got k2 and true. K3 and false. I'm kind of moving quickly through these dictionaries because I assume y'all have had some experience with dictionaries up until this point because you're working with objects that you create now. So if some of this is moving a little too fast for you, I encourage you to check some of the dictionary memory diagrams videos. All right, well, let's move on. We're almost done here, but we still need a way to access this dictionary within our stack. So we take our ID and we store it over in Lenovo Seats. This is a great time. Notice that I completely forgot to do that with class. If we hadn't done this, we'd have no way of knowing how to create that class. So we do that here. Apologies. All right, we've created our dictionary. We're ready to move on to line 20. Line 20 creates another global variable. We'll call that show. And this variable is of type concert. As a computer, I see concert and I'm like, well, that's not built into my library, but I have stored concert in globals and I do know how to find it if I need it. So we're good to go. We move on and try to assign to it a value. Well, that value is a function call. In particular, it's a function call of the exact same name as its type. Now, this is a special function. It's called a constructor. Uh, Constructors are how we build an object of a class, an instance of that class. So when I see a function call and it is of the same type, or it has the same name as the type, I'm going to do something a little weird. Normally, when you see a function call, like let's see assign seats, you see this assign seats function call, like cool, I'm going to go look for a function definition that has assigned seats in it. However, with this particular type, this constructor, instead of looking for a function definition with concert in it, we take it A to the class that we specified. So we specified this to be of type concert. We're going to take this to the concert class and we're going to scan through it to look for what's called the init method. Think of init as like initializing. We're initializing this object. So the init method is the constructor of the concert object. Cool. So now that we know what the name of this function is that we're building, go ahead and create our function frame. So special thing about class functions, we call them methods. And whenever you're creating a method frame, you have to first specify the class that it's is a part of. So this is the concert class. We denote that it's a class with this little hashtag. And then the name of the function is underscore underscore or dunderscore init underscore. Just like any function, a method, we got to give it a return address and a little return value slot. And then we check to see what parameters we need. Well, we need a self parameter, an A parameter, and an S parameter. So we'll create a self parameter, A parameter, and an S parameter. And then we go back to our function call to see what to put in there. We got A, we have S. Let's just we'll worry about the other one later. Let's just fill this out. So A is going to be assigned the value travesty, and S is going to be assigned the value stored at Lenovo seats within our globals, which is where this was called. So ID1. So A is going to be travesty, and S is going to be ID1. A just refers to the string travesty. S refers to this dictionary object. Points to it. Great. We got two out of the way. Something weird is going on. I have two arguments inside of this function call, but I have three parameters here. So the question is, what is this self? The self is the object. Think of self as how we refer to where this object will be stored in the heap. So until we create this object in the heap, we have nothing to put into self. It'll make a little bit more sense once we start working on it. So let's go ahead and make object. Well, what is this object? Well, concert object. We give it an ID. Next available ID is ID2. Concert object. Now, what do we put for these keys and these values? Excuse me. I shouldn't have said keys and values. It does look a whole lot like a dictionary, though. What are we doing? Well, we need to put in these attributes as the left side of the column. So attributes will be artist and seats. These attributes are the thing that make this object a concert object. Without them, we have no use for this thing. We don't know what it is. These attributes help define this concert object. And we leave these empty, right? We haven't at this point, we're still building out this function definition. We haven't been told what to put in here. But we have been told, hey, we need a self, so create this object. So we take this ID and we store it in self. ID2. We have an empty object, and let's see what init tells us to do. We step in. First thing we're asked to do is say self.artist is set to A. Well, some of this makes sense. A is travesty, so whatever we're doing, we're assigning to it the value travesty, right? But this right here is a little bit new. But we can infer some things. We're saying self. Well, self is ID2, so we are referring to this object here. And then artist. Well, artist is in here. So maybe we're trying to assign A this little slot right here. And that's indeed what we're doing. I try to think of these as like little road maps, right? Self is the street, right? That street takes us here. We're looking for the artist house. So we head to the artist house and we want to put travesty inside of there. Travesty is our person inside of the house. This is how we find a person. So self is the street, takes us to the object. We access the artist's house, and we assign it a value or a person. So we assign it, in particular, the value A, which is travesty. So over here, I'm going to write travesty. Great. So we've done that. So let's move on to line 7. Line 7, similar thing. We're following this roadmap to self. It takes us to this object. We're looking for the seats house. Seats is right there. And we're assigning to the slot that's associated with it. S is ID 1. We put ID 1 here. Boom. We have ourselves a nested data structure. We have concert object. Inside of it is stored a reference to another object, dictionary. All right, cool. We are almost done. We have hit the end of our method definition. However, something funny is happening. Something really funny is happening, which is that I completely forgot to put a return address in. So I'm going to go ahead and do that really quick. Line 19, right? The line, oops, excuse me, line 20. Right? The line that this kicked off this whole frame. All right. So let's dial in on something really quick. Init method, notice, does not specify any kind of return type, right? This is odd, right? Even it's oftentimes it's some sort of a value, like an integer or a dictionary. And if it's not, if it doesn't return anything at all, oftentimes you'll see none there. But the init method specifically has no return value. It also doesn't have a return statement, right? If there is a return value, oftentimes you'll see a return statement of some sort. However, the init method is special in that it's the only method that you're going to be working with that does return something despite all these observations we've made. In particular, it returns the value of self. So let's do that, and then we'll see why that makes sense. We're going to put ID2 into our return value slot. And then as soon as we have a return value in our return value slot, we immediately take it back to our return address. The function call gets replaced by its return address, or excuse me, by its return value. So ID2. And then we're storing that in our global variable show. ID2 goes into show. If you think back, or if you think on this, this kind of makes sense, right? We wanted to create an object that we could, a concert object that we could store and show. We go into our init method to create that object. The only way to actually access that object is with this ID stored in self. Right? As soon as we leave this frame, it goes out of scope and we're back in our globals. If we don't have this ID here to store, we have no way of accessing this object. It's just completely locked to us. So if you're ever going through a memory diagram and you realize that you have no way, you have no ID where you're working to access some value in the stack, start retracing your steps. You probably missed something. In particular with the class work we do, you probably forgot to return self. So with that done, we are done with line 20. We've created our objects. We're ready to move on. Line 21 actually does some stuff with this object. In fact, it calls another method on that object. So assign seats, a function. We know it's a function because of these parentheses. We're calling it on the show object. Well, I got a function call. Now to create new frame. Assign seats is part of the concert class. So we have to start this out with concert. Letting them know the class. Hashtag. And then the name of the function, which in this case is assign seats. Give it a return address and a return value slot. Return address, line 21. Don't know the return value yet. Do know that the return value is of type none, so if you want, you can go ahead and fill that in. And then we're ready to build out our parameters. Well, we have a self parameter. We have a wanted seats parameter. And we have a name parameter. Well, just like last time, let's put off defining self. You have wanted seats declared and we have name declared. So let's go ahead and add those. So wanted seats is of type list of strings. Well, this is kind of weird. I don't have a list of strings over here yet. Where did that go? Well, we're actually creating it inside of this argument. So this argument is what creates this list of strings. So we all know how to make lists of strings. Over in our heap, we grab the next available ID, ID 3. It's of type list of strings. And we have two values stored in it. We have K2, K3. K2 and K, K3. Cool. Now that we have that, we can go ahead and add it to our parameter. So ID3 goes into wanted seats. Now this is kind of interesting. We've created this list, assigned it to the parameter. As soon as this goes out of scope, right, as soon as we go back to globals, we're going to lose this. Unless we store it, say, like in another object or that we have reference to, we're going to lose this list. Which could be okay. You know, maybe we just need this list in order to do something with this assigned seats. But this is something to keep in mind. Right now, the only access to this list is within this frame. And as soon as this frame goes out of scope, as soon as we go back to line 21, we've lost this. All right, let's move on now. We've built out our wanted seats. Now we're ready for name. Name is just K, string K. Over here, just write K. Someone's name. Cool name. Finally, we got to do something with this self. This is a little weird, but bear with me. Self is the object that assigned seats is called on. There's two parameters here. I got three, or excuse me, two arguments here. I got three parameters here. Well, where's that third one? Well, the third argument, or rather, I should say the first argument is always going to be object that assigned seats that the method was called on. We know show is an object, right? In particular, this object over here. So show is the object, and assigned seats is getting called on it. So the self, in this case, is whatever's stored at show. Well, ID2 is stored at show, so ID2 is stored in self. Great. All right, well, let's move in. Built out our parameters. We have a return address and return value slot. We are ready to step in. First line, coming in strong, we have a for loop. What is this for loop doing? Well, it's saying, hey, for every element in some data structure do the following. Well, the data structure is wanted seats, and wanted seats is a list of strings. We're saying for every single element, starting with this first one, do the following. We might not actually do anything with this element. What this is saying is, hey, there's currently 2 elements in this list. Do the following twice. In this case, we will be doing something with it, but this is just something to keep in mind. Cool. So what is seat on the first loop through? Well, seat is the first element in this list. So we're going to create a little temporary variable here. We're going to call it seat, and we're storing in it value, oh my goodness, storing in it the value k2. All right. Now what do we do? Well, we're inside of our loop now, and we're saying if seat in self.seats. Well, seat is k2. So what are we doing? We're checking to see if k2 is in self.seats. Self, think of it as like a roadmap. Self is the street, and we are saying self.seats. Self takes us to this object. We're accessing the seats value, the seats row. Well, that takes us here. Well, what is ID1? ID1 is this whole dictionary. So we're checking really to see if K2 is somewhere in here. And when you loop through a dictionary with an if in, what you're really doing is you're looking to see if the thing you're looking for is in this column right here. Well, K2 is in this column, right? K2 is in this column. So this whole thing evaluates true. Great. Well, let's step in then. Creating temporary variable called available. So let's do that. Available. And what are we doing? We're assigning to it type Boolean whatever we get from self.seats at seat. Oh, geez. Okay. Don't overthink this. Self. Self takes us here, right? So we're looking at this object. Dot seats. Dot seats takes us here. So now we're looking at this object. Well, this object is a dictionary. So now we're looking at this dictionary. We're saying access the seat key. Well, seat is K2. So we're accessing this, grabbing the value stored with it. The true is assigned to available. Let me do that one more time real quick. We'll have another chance to do it. Self.seat at seat. Self and seat takes us here, brings us all the way up here at seat. Looking here. Cool. Right. Now we have created that local variable. We're ready to move on to line 13. 13 says, is available. Well, that's weird. Well, just conditional statements have to evaluate to true in order to move in. So, is available true? Available is true. So this whole thing is just if true. Well, we're good to move in. Excuse me. What are we doing? Well, first thing we're doing is we're printing. We're printing an F string. We're printing whatever stored at name, not seat, whatever stored at seat, to C, whatever stored at self.artist. Okay, let's build this out. We know we're creating a string. So, what is name? Well, name is K. The first thing we're going to put into output is K. We're adding to it this string right here. So, bought seat. Well, what's stored at seat? Seat is K2. Throw in K2. Goodness gracious. Sorry about that, y'all. Okay. Uh, sorry, where were we? Let's start that over. So we're printing out this whole line right here. We're sending all of this to output. A its name is whatever's stored in this name slot. So K. So we write K. We write bought seat. So bought seat. And whatever's stored at seat. Well, seat is K2. So we threw in a K2 here. And then we're moving on to C. So to C. And then whatever's stored at self.artist. Well, self takes us here. Not artist takes us travesty. K bought C K2 to see travesty, who is, by the way, an extremely dope hip hop artist. Definitely check him out on Spotify. He's got a couple albums called Code Flows, and you might recognize some of the terminology in those tracks. Just a side note, notice I did not put quotes around here. When you're printing stuff to output, you always want it to look like what it would in the terminal. When you print a string to output, there are no quotes on it in the terminal. Cool. All right, we are done with line 14. Line 15. Line 15 says self.seats at seat set to false. Great. Well, what does that mean? Well, we're following our roadmap. Self takes us here. So this is a street. Self. We're going to the self street. Takes us to this concert object. That's seats. Well, this takes us to, oh shoot, another street. That's kind of annoying, but let's do it. Then at seat. Well, seat is K2. We're accessing the value stored at K2, which is true, and we're assigning it the value false. True becomes false. Kind of makes sense, right? If K bought a seat in K2, that seat's not available anymore. All right, done with line 15. Move on to line 16. Line 16 is an else statement. Well, we entered the if statement, so we ignore that else statement. And we've hit the end of our indented block underneath the for loop, so we loop back up. Well, what were we doing? Well, we were looping through every single value in wanted seats. Well, wanted seats is this list of strings. Did have K2, so now seat becomes K3. Cross that out. We type right in K3. This is a little quote right here, by the way. We're running out of space. All right. So we're ready to rock and roll. Excuse me. Line 11 checks to see if seat is in self.seat. Well, K3 is seat, so we're checking to see if K3 is in self.seats. That takes us up to our dictionary. Seats. We're checking to see if K3 is in this column. It is indeed, so we're ready to step into our if statement. Our if statement, if block, or excuse me, we're ready to step into our if block. Our if block assigns self.seat at seats to be available. So whatever this is, we're going to assign to it whatever value we find in self.seats@seat. So self takes us here. Seats takes us to this dictionary. Now we're looking for A3, right? A3, seat in here. Well, A3 accesses this value. So what are we doing? We're assigning this value to be available. True is false here. Great. What do we do now? Well, we hit line 13. Line 13 says if available. Well, available's value now is false. So this statement evaluates to false. Available evaluates to false. So we cannot step into here. Instead, we move to our else statement. What does our else statement do? Well, it just prints something. It prints seat. Well, let's start with this. Seat, and then the value stored at seat, which is K3, is unavailable. And then colon, parenthesis, and face. Cool. Done with that. Hit the end of our indented block for our for loop, and we have indeed hit the end of our indented block for assigned seats. So we go back to our return address. We didn't have a return value here. We go back to our return address, which is line 21, and we're done. All we did here was just call a function on show, and when we're done with that, we moved on, and that was the end. Okay. I do want to make one quick note, which is notice that I have two lines here. This was just for saving space sake. If you were to do this in a quiz setting, I would like throw an arrow around to show that you recognize that this isn't a second entry. This is just one line of code or of output, and then this would be the second line of output. Other than that, this is a pretty comprehensive example of working with a class that you've created. It's also really useful for working with nested data structures, so useful for working with scope and seeing things that are created in one scope and then we don't actually end up having access to when we come back to globals. But yeah, hopefully this was all helpful. If you're confused about any of this or you want to walk through it with someone, please come to office hours or tutoring. There's lots of TAs that are anxious to help you understand this. Alrighty. Oh, and go check out Travesty on Spotify. They got some good code flows. Great. Thank you so much, and I hope you all have a good one.